Okay, let's look at example 8. A load of 250 kg is hung by a crane's cable. The load is pulled by a horizontal force such that the cable makes a 30-degree angle to the vertical plane. If the load is in the equilibrium, calculate the magnitude of the tension in the cable, the magnitude of the horizontal force. Okay, so we are given a situation here, but we are not given a diagram, so meaning that we need to draw our own diagram based on the situation given. Okay, so first of all, we have a load with a mass of 250 kg. So this load is hung by a crane's cable. So we have a cable here. And then the load is pulled by a horizontal force. So the keyword here, pulled by a horizontal force, meaning that we have external force. Okay, we are exerting an external force such that the cable makes a 30-degree angle to the vertical plane. Okay, so now we can imagine like this. So this is a cable and this is the load. So initially it's just hanging on itself. Here, the cable, the load. And then what happened is the load is pulled by a horizontal force. Okay, ditarik oleh force dekat horizontal. So it doesn't say if it's to the right or to the left. It doesn't say, but it says here such that the cable makes a 30-degree angle to the vertical plane. So this is the cable, it must make a 30-degree angle to the vertical plane. So either macam ni 30 degree ataupun macam ni 30 degree. So any way is possible lah. So we can just assume here we exert a force to the right here. So maksudnya kita tarik lah dekat sini, tarik dia ke kanan, and then what happen, this cable will go like this. So it will go like this, and then it will make an angle 30 degree here. So after it makes an angle 30 degree, so kita boleh lukis lah dekat sini. Okay, let me draw that one again. Here. So this one is the dotted line. So apabila kita sudah make an angle, apabila kita sudah pull the load to the right, so we pull the load to the right by an external force, and then make an angle of 30 degree to the vertical plane. So it matches the situation here lah. Based on the situation given, so kita letakkan macam ni lah diagram dia. Okay, and now given the condition here, if the load is in the equilibrium, okay, load is in equilibrium. So remember, bila kita dibagi condition equilibrium, kita tahu sum of Fy is equal to 0, and then sum of Fx is also equal to 0. And then we need to calculate the tension and the force. Okay, so first thing we need to do is we need to identify the forces on this object. So object kita dekat sini adalah the load. Okay, now we know that first, yang paling basic adalah load dia akan ada, object dia akan ada force, weight, which is going downward. Dia akan ada force, weight force, which is going downward, W, which is equal to mg. And then dia, since kita sudah lukis external force going to the right, and then since dia ada cable, so remember kalau ada cable, dia akan ada force away from the cable, away from the object, which is the tension force. Okay, so these are all the forces that we have. Okay, now that we need to transfer this one to FBD. So this is the FBD. We start with dot, and then after that kita just follow. Ke bawah adalah W, ke kanan adalah F, force, and then we have here is tension. Okay, so now since angle ni dekat sini, sebenarnya dia macam ni kan, angle dekat sini akan sama dengan angle dekat sini. So maksudnya 30 degree itu adalah di sini. Okay, that 30 degree is actually here, because if we do it like this, okay, if we do it like this, kita tahu angle di sini akan sama dengan angle dekat sini. Okay, so that is our FBD. So selepas lukis FBD, kita kena lukis table. Okay, lukis table macam biasa, di mana kita akan bahagikan kepada X component dan Y component. So we have X component and then Y component. And then force yang kita ada, we have 3, tension, force and weight. So buat 3 kolom. Okay, and then masukkan setiap force yang ada, which is tension, force and weight. Okay, kita tengok satu-satu. Tension dekat sini. So tension here, we are not given the value. Are we given the value? We're not given the value. Actually tension yang kita mau. Okay, so basically apa yang kita mau adalah tension, and soalan B, force. So we are not given the value here. Okay, but we can transfer the information that we have. Okay, tension here, we need to resolve into okay, Y and X component. So X component dia dekat sini adalah to the left. To the left meaning that it is negative. Negative T. And since the angle is on Y axis, bermaksud dia akan jadi sine. Negative sine 30. So untuk Y component pula, dia ke atas, so positive. So positive T cos 30. So kalau dekat sini sine, maksudnya the opposite one will be cos. Cos sebab angle tu memang dekat Y axis. Okay, so F. Now F, dia ngam-ngam dekat horizontal X axis. So bermaksud hanya di X axis sahaja kita ada value, Y axis tiada value. So and now dia ke kanan, so just positive F. We don't know the value, let's just put F first. And then weight, okay, weight kita ada ke bawah saja, which is only on Y axis. So hanya di Y axis saja ada value, X axis tiada value. So Y axis, it's going downward. Weight force going downward, which means negative W, which means equal to mg. Okay, kita boleh terus buat calculation dekat sini, so that we remember that negative it will be negative mass berapa tadi? Mass 250 times with gravity 9.81. Okay, boleh terus masukkan value dekat sini. So nanti bila kita keluarkan equation, we are not going to get confused lah. And then the sum here must be 0, here pun, dan jadi sama dengan kosong. Okay, so now what we want to find is the value for T and the value for F. Okay, so let me make this smaller. Okay, so now kita keluarkan equation here for this one untuk X component, which is sama dengan kosong. So we have negative T sin 30 plus F plus 0 equal to 0. And then we have y component plus t cos 30 minus, since kat sini minus, kita ambil yang ni, minus 250 9.81 equal to 0. So, we have two equation. Okay, untuk equation yang pertama, let me label, this is the first equation. Untuk equation yang pertama, kita ada dua unknown, so we cannot solve this one yet. Untuk equation yang kedua, kita hanya ada satu unknown, so we can solve this one, which means we can get the value for t. So you just solve and then you will get t is equal to 2839.9 Newton. So ni sudah menjawab soalan A, di mana soalan A minta the magnitude. Okay, only magnitude, so you don't need to find the angle, because basically we already have the angle here, direction. So magnitude of tension, and then soalan B, magnitude of force. So now that we have the value for the t, we can use the first equation. Just masukkan value for t here. Negative 2831.9 sin 30 plus f equal to 0. So f will be equal to 1416 Newton. Okay, you should be able to get f is positive, because dalam jadual kita sudah tahu f must be positive because it is going to the right. Okay, so since dia minta magnitude sahaja, you don't need to calculate the direction, because technically we already know the direction here, which is for t is 30 degree, for f it's going to the right. Okay, so that's all for example 8.